Hello, everyone. I'm Sean Buckley, editor-in-chief of Lightwave, and it's my pleasure to welcome you to today's Lightwave webcast, in which we'll discuss building smarter fiber networks for metro and long-haul data center interconnect (DCI). Today's webinar is brought to us today by our sponsor, AFL. Thanks, AFL, for sponsoring today's webinar. Joining us today from AFL is, of course, Carson Joy, product line manager for AFL. But before I hand off things to Carson, let me quickly review our webcast setup for those of you who may be joining us for the first time or for the first time in a long time. I'll start with the Ask a Question box you see near the slide area. I invite you to feel free to use this to ask questions at any time during the event today. It's a great topic, so I'm hoping a lot will come in. To submit a question, just click in that box, type in your question, and hit the send button. We'll address your questions after Carson has finished his presentation. Now, in the event that you run into a technical problem during the presentation, you can call for help via the Q&A tool. Just describe your problem, hit the question submission button, and Milan, who is today's webcast technician, will be happy to help you out. Next, if you know of someone that might benefit from seeing this webcast, or you just want to revisit the presentation yourself, this event will be available on demand from our webcast archive for the next several months. We'll send you an email link with the link to the archive sometime in the next day or so that you should feel free to forward to your coworkers. And the archive version of the webcast will also be accessible from the webcast archive of our section of our website, which you can reach via our homepage at www.lightwaveonline.com. If you like, you'll be able to download a copy of Carson's slides via the Event Resources tab. You should see on your screens right below the Ask a Question box. Just click on the tab for a few slide files. Finally, so with that, let's begin our look at data center interconnection and smarter fiber networks. Carson, the floor is yours.
Thanks, Sean. Appreciate the introduction there, and thanks to everyone online joining. Welcome back from lunch on the East Coast, and for everyone else joining across the globe for this review on a very timely topic on data center interconnect for metro and long haul builds. So the goal today is to cover from a pretty high level what's going on in the latest on data center interconnect for metro and long haul networks, the players involved, and the current state, and look a little bit at the future state as well. So please provide those questions in the chat, as Sean mentioned, throughout the presentation. We'll cover them at the end. So the agenda today will cover an introduction. We'll baseline level set us on what we're talking about and what the avenues for data center interconnect are today. We'll cover some innovations and advancements in fiber optic cable that are enabling faster deployments and smarter deployments of data center interconnect. We'll cover that on the connectivity side as well as equipment. We'll look at some future trends in optical fiber, and then we'll wrap it all up and leave some time at the end for questions. So on the introduction side, let's start with some definitions. So mention metro and long haul in the title here. So metro networks, as the name would suggest, are fiber networks that connect metropolitan areas. So often hear terms like a ring or something similar to that is an optical network that goes around a city or a metro area. And then a long haul network, also as the name would suggest, is a fiber network spanning long distances between cities and regions, even continents in some cases. And a data center interconnect is a network that simply connects two or more data centers. And that can either be within a metro environment or a long haul, but both of those are critical in the deployment of DCI. The piece parts within metro and long haul are fairly similar. Some of the differences that you might see between those related to the distances that they cover would be the optics or active components that are going over an optical fiber network. But the piece parts, again, fairly similar between metro and long haul, but just to differentiate those definitions as we talk about DCI, that is where we'll start. So next, let's talk about some trends. So this has been a very hot space. Obviously, AI boom and data center deployment over the last 12 to 18 plus months has covered many headlines, and the interconnect aspect of that is no exception. Maybe a little less on the headline side, but critical to the overall in game when it comes to deployment and applications through data centers. So the global market estimated by some to be close to 19 billion by 2030. Honestly, a modest CAGR growth there of just about 13% from where we stand today might be a little understated, but what's not included in that number is actually the data center build itself. That is just the interconnect space of this. Measured by many in the trillions on the overall data center number, which is hard to comprehend. I saw a quote earlier this week from an executive that said, once you start getting to trillions, does it really matter? It's just a big number. So that would certainly be the case for the overall spend. But again, that's just for this market that we're talking about specifically today and data center interconnect. 1,000 plus hyperscale facilities globally, 150 being added annually. You can see a map there to the right from INREL. That's just for the U.S. Interesting about the 1,000 plus hyperscale facilities within the lower 48 there of the U.S. is a little over half estimated of the megawatt capacity of data centers today. So a lot of focus on the U.S., but this is certainly a global expansion as well. Interesting also in the INREL graph there or chart, you can see the white line as the fiber optic backbones for these data center clusters. Certainly estimated there's a whole lot more there than you could show on that map, but good view of the long haul deployment requirement for this DCI build. And then AI is changing the game in more ways than one, but requiring estimates of 10 to 100 times more bandwidth than traditional applications is a fiber, let's say, data hungry application. And the transmission medium of the day for that bandwidth is optical fiber and for the foreseeable future. Theoretical bandwidth of fiber is much higher than we're at today as active equipment continues to get better. These data pipelines of optical fiber that are being deployed today will be working for 30 plus years after they're installed, really through their lifetime. So key drivers of that, everyone's using multi-cloud strategies. That's driving the demand. AI is driving the demand. Interesting here, edge compute and data sovereignty is really driving the need for localized data centers, which means more metro builds. So not these massive megawatt, gigawatt level data centers that make headlines, but also smaller regionalized ones that require metro networks to support those as well. The infrastructure pressure, on a positive note, we're pumping more data into each fiber as 800 gigabits per second is becoming more normal. 400 gig now viewed as the baseline. Some limitations there. I talked about optics on metro and long haul. Going 800 gig over long haul deployments can pose some challenges just on reach, but certainly within the data center and some metro networks starting to see 800 gig deployment, which is good for the pressure required because you're getting more data out of it, but it's not enough. So major metros today, a lot of capacity constraints. No one could have foreseen the demand of AI and these data center build outs. And these deployments for 5G or fiber to the home did not foresee an application that was going to take 10 to 100 times the bandwidth that traditional applications have taken. And just to put in perspective, single AI facility taking 50 to 100 plus terabytes of capacity. That's basically, from a fiber to the home application, that's basically a city, a small city in one building, that from a bandwidth requirement is really unfathomable, and it's pushing the market to to effectively deploy more fiber faster because we're consuming it faster than we can build it at this point. So a lot of data points here to say need more bandwidth and the industry needs it faster. So what are the challenges in getting there? Urban environments are dense. They're largely built out. There's not a lot of space, limited duct space, congested infrastructure mentioned previously. Permitting continues to be a challenge, will continue to be a challenge. Approvals from a city standpoint, oftentimes more challenging than in rural environments. The metro build outs are a challenge. Long haul, also difficult to scale there. Demand is increasing for high capacity, long distance. These are going over hundreds, thousands of miles. Takes manpower to get there, so labor limitations. This industry is no is not immune to labor challenges and skilled fiber technicians in construction. When there's high demand and low supply, labor costs are increasing, which is impacting deployment budgets. But even more so than the cost is just availability at any cost to get this installed. Deployment speed requirements. This is needed yesterday, and the pressure to accelerate network builds is felt by, I'm sure, many people on this call, and as a manufacturer, we're no stranger to that as well. So speed is the name of the game, and that is a challenge with many constraints that are out there today. So let's move into some of the materials that go into this and some of the innovations in fiber optic cable and installation specifically that are benefiting smarter and faster deployments of the needs for the industry today. So we'll start with high density cables. Putting more fiber into a smaller space is critical for these deployments. So from a loose tube perspective, micro cables are critically important in applications. So shrinking down traditional fiber cables for increased fiber density. So in the picture on the top right there, you have a 144 fiber non-armored traditional loose tube cable at a little over a ½ inch or around 16 millimeters. As you scale down, the second to the right side there is also 144 fibers. Same type of fiber, 250 micron fiber, 50% the size. So much smaller, about 8 millimeters, capable in a 12/710 or 1410 microduct, which is extremely valuable for overbuild or new build situations today to increase fiber density. And then you step down one more level to the right there, incorporate 200 micron fibers, and you get another 20% reduction in size down to about 6 millimeters. So continuing to shrink down cables, maximize conduit space. Real estate is very expensive. Labor, as we've seen, is very expensive. Key to put as much fiber into a small space as possible or practical in these DCI builds. And then as you see the need for bandwidth increase, the need for higher fiber count cables per deployment are imminent upon us. And that's where ribbon cables can come in, specifically intermittently bonded ribbon cables. So the industry has evolved from loose tube cables to flat ribbon cables or matrix ribbon cables for high fiber counts, now to collapsible or intermittently bonded ribbon products. So these are high density, compact designs that enable mass fusion splicing that have gotten us to kind of key milestones in the industry, like an 864 fiber cable in a 14 millimeter microduct, in some cases 13 millimeters, which is huge from a density standpoint and critical in deployment for these types of DCI networks. So how are those enabled? Microducts, microcables typically should go in microduct pathways. So similar to microcables, taking conduits and shrinking them down into smaller sizes. So enabling faster installation. These are, along with the fiber cables, really designed for air assisted or jetting applications, which can speed up deployment, overriding an existing brownfield deployment with a microduct and a high fiber count cable, and then bundled microducts available for greenfield new build applications. This is really maximizing fiber density, um, trying to future proof. I put future proof there in quotes because we've quickly learned that enough is not enough. So at least, let's say, at least a better chance of future proofing your architecture, and then an overall lower total cost of ownership from just taking up less space, and putting more fibers in that space. So what do the two of those look like? Just a practical application here. This was a presentation we provided to a customer that was accustomed to two-inch conduits with traditional cables. So it was either a loose tube or a flat ribbon cable, sometimes overriding that with an interduct, but oftentimes just putting one cable in there, and really tapped out at potentially 432 per pathway or 864 fibers for the two. Expensive to put both of those conduits in. So what's the bundled microduct plus micro cable pathway look like for that? How about just one bore, and then 7 microducts in there, easily putting 432 fibers in each pathway, potentially 864 as well, to really give you a better shot as at a future-proof build out, and maximizing the value of that pathway. As we'll see in some later slides, construction is timely, construction is expensive. At the end of the day, fiber and conduit are relatively inexpensive compared to those things. So if you have one shot on these long haul routes or even metro builds, in a greenfield application, something like a bundled microduct with micro cables significantly helps your ability to meet the demands of the day and potentially tomorrow. All right, so from a connectivity standpoint, if you've been in the field at all, you've probably seen a handheld that looks something like this. Very crowded, not a lot of space to work with. I think there's even a water bottle in this picture here. So where are the innovations on the non-cable and conduit side that can enable these DCI networks? So first is in splice closure. So really similar to microducts and microcables, shrinking down the footprint of splice closure, but still highly capable of high fiber count designs, mass fusion splicing, single fusion splicing. This is example from AFL's Apex splice closure, if you're familiar with it, but similar ones out there too, to protect fibers both above ground and below grade. Quick, easy installation, saving time on the splicing aspect of these build outs. Toolless removal, integrated O-ring, simple innovations like that to ensure an easy deployment, and one that will work, and without rework or going back in with cases flooded. A key element here also, especially when we talk about leasing out networks, if you have the ability to, if it's not required by a contract, to separate those cables out from a handhole or a splice closure standpoint, this is a major de-risking capability, with the gel sealed ports being individual. So if you ever have to go back into a closure, you're not messing with the sealing of the other cables that are in there. Also, an inner organizer system that you can organize slack with, um, an integrated separator that can separate loose tube cables from ribbon to protect the bare ribbon that's routed in the closure. and a compact size that could fit up to 3,456 fibers into closure mass fusion, and a universal splice module that can do single fusion splicing as well as um, ribbon and easily stack those, which is a key to the density capability in these types of closures. So another area where you might not necessarily consider innovation often would be in vault space, but an innovative solution here on a collapsible or a hinged vault, enabling 3 to 4 times as much per truckload. So 50 units of a traditional handhole on a flatbed, up to 200 in this type of size. Tier 15, Tier 22 options available. Um, Very lightweight. These are can be deployed, picked up by one person, thrown into the back of a truck for a long haul or a metro deployment for a faster deployment relative to some concrete based heavier handholds. Efficient, just as efficient in shipping as it is in storage as well. Um, and a great solution on a smarter network with these types of products, um, taking up less space and being able to deploy it faster. And then eventually you got to splice it. So some innovations in fusion splicing we've seen, trying to keep up with the industry, more innovations and newer equipment to come in the near future. But ribbon splicing huge when it comes to these high fiber count, long haul deployments. So mass fusion splicing capability, easily switching between 200 micron fiber and 250 micron fiber, with field replaceable V grooves that can just be changed with a screwdriver, and easily identifiable holders, but between different sizes of fibers that you'll see out there. Also ribbonizing when it comes to legacy networks or new deployments with loose tube cables, a universal tool there, and also seen some innovations in the ribbonizers to go glueless, so there's no mess involved in ribbonizing loose tube cables, and ultimately speeding up the deployment when it comes to splicing and fusing cables together. So, what does all this mean? So this is taken from a real case study we at AFL did with a customer, worked with engineering departments um, and management. Some made some edits here just for confidentiality, and also some ranges to show that this really is a case by case basis, but give you an example of some of the advantages that we talked about so far. So um, the biggest element from a cost saving standpoint is certainly when it comes to micro cables and microduct, the ability to use the existing pathway. I mentioned previously it's expensive to bore or trench a new pathway, and any ability to reduce that is a significant savings. So in this case, between 10 to 15% of the time available to override or use an existing pathway instead of building a new one, and those savings per 100 mile were significant. Also reducing splice points, that was based on using a micro cable versus a traditional cable and getting longer lengths per reel, was able to reduce splice points between varied between 25 and 60% based on the length of the cable they were receiving before, which is huge for a long haul deployment. So that savings can add up significantly, as well as splicing is timely and expensive. And then reducing splice time at the remaining splice points that was based on an easier to handle fiber cable, and again, related to smaller cable, reduced shipping and handling costs. Micro cables also enabled smaller handholds, and there was a hardware savings associated with that, although minimal. And then installation savings from using a new splice closure as well was a small amount. But all that in aggregate per 100 miles was a savings between 2.7 and 4.2 million dollars, as you can see there. And I'd hesitate to say more important, but arguably more important than the dollar savings, and something that wasn't quantifiable from this particular case, but is very pertinent for data center interconnect build out, was the time savings, specifically on the ability to use the existing pathway, not having to go through permits, not having to get additional contractors and install over that time period was a huge time savings, um, one that we didn't put together but could have, because speed to revenue. If you've read anything about AI build outs or what these hyperscalers are talking about, more more fearful to them of the bubble bursting or this not panning out is being late to the party. So time is money, as it always is, and the timing aspect of this is critical when it comes to existing routes that many traditional service providers have out there, and I'm sure are bidding offers right now to lease out or build out a network for data center interconnect. So using existing pathway, leveraging smaller fiber cables and microduct overrides of huge value, really an unquantifiable amount of value there when it comes to a case overview. So next here, want to talk about just a few trends in fiber, what we're seeing now and what we're expecting in the future, and how that will impact build outs. So the first one is smaller than 200 micron fibers, the individual fibers themselves. So fiber started in the 80s at basically 250 micron for outside plant deployment and loose tube environments. That's 125 micron cladding. So cladding is important because that's actually what's used when splicing the fibers together once you strip the coating off. So the latest fibers, which are really pushing probably 15 years old now, was shrinking that down from 250 micron fiber to 200 micron fiber. And you saw the value um, in one of the earlier slides from the cable standpoint at 144 fibers, getting about 20% smaller cable diameter, which can be significant in some microduct applications overall. So the key with 200 micron fiber is that it was still 125 micron clad. So still some complaints in the field on splicing 200 to 250, and I understand there's some complications there. But once you strip the coating off, um, it's really the same. You got to get the right equipment for your splicer, uh, but very similar when it comes to handling and splicing. So the next generation of fibers are looking to be somewhere around 160 micron in coating diameter. So that's reducing another 20% or so from the 200 micron fibers that are available today. Key difference here is from a fiber integrity standpoint, the cladding is going to be smaller. So going from 125 down to 80 micron clad, which means there's a whole host of new challenges when it comes to splicing these fibers together. 80 micron to 80 micron or 160 to 160. Fusion splicing today, no problem. Even in ribbon, not a problem. The challenge is anytime you're going to deploy something like this, you're going to need, at some point, you're going to likely need to splice to a legacy fiber, whether that's 200 or 250. So that's the challenge to manufacturers today, what AFL is working on. But you see some smaller fibers out, 180 micron, a little bit out there today, 160 will be the next wave over the next couple of years, and targeting to get us to really critical levels from micro cable standpoint. We're talking about potential to get 1728 fiber and an 1814 microduct. Potentially could be a huge advantage over what's really maxed out at 864 today. A whole host of other applications as well, where a 20% reduction in size of a cable could be of significant value. So more to come on that, but those starting to see some of that today. So uh, really different from density plays to just reduce the size of cables. There's a new innovation in fiber that we're really seeing today in hollow core fiber. So as the name would suggest, this is a fiber that's manufactured with air in the core, or a empty core, for lack of a better term, instead of glass as standard traditional single mode fiber is today. And the scientific reality of that is the light transmits faster in air than it does in glass. So the primary goal or initial goal of hollow core fiber is lower latency, which effectively means, and you can see there from the Microsoft visual, 47% improvement in speed. So that's effectively taken, when we're talking about data center interconnect, taking data centers that are very long distances apart. And when you operate on hollow core fiber, it's like they're very close to each other compared to traditional single mode fiber. There are some secondary benefits to hollow core fiber as well. Lower attenuation possible, more power to put, more data to put in in a um, in a single strand of fiber that are really still in the kind of experimental stage today. But at the point up there says active deployments and use cases for hollow core are at DCI networks today. So we're seeing this today, and it's really over the last 12 months or so has really taken off and become a bigger part, gone from true R&D to field deployment. Still a lot of work to do on hollow core, but a lot more information than we had 12 months or so on it. So finally, from a fiber trend standpoint, next generation is multi-core fiber. So similar to hollow core, as the name would suggest, multiple cores in a single strand of fiber. So different from hollow core, this is solving a density issue. So increasing fiber density, reducing, the need, basically quadrupling the fiber density by 4 cores compared to 1. You can see in the graphic there to the right. Some trade-offs here. There are some optical challenges with multi-core. It's been around from a R&D standpoint for many years. It was 5+ years ago that AFL deployed a multi-core trial cable. But nonlinear effects, intercore, crosstalk, those types of optical challenges are still being worked through. And then there's field deployment challenges. If you thought splicing 160 micron fiber was a challenge, try splicing 4 of them together, making sure you don't splice core 1 to core 3. Repair standpoint, there are still some practical challenges to overcome when it comes to multi-core, but some promise that that this type of fiber could, in maybe specific use cases, really provide a lift from a bandwidth standpoint and fiber density overall. All right, with that, I'll wrap it up here with a summary. So key takeaways from this review: flexibility, density, reliability. Um, the market is requiring flexibility, requiring density, and reliability too. And these are challenging to balance. The 3 of them As mentioned previously on some of the product solutions that are available there are some product solutions available today to support this, but it is changing daily, and the requirements are changing daily, but they are trending up, and requirements are trending up as new AI applications are coming out on a daily basis. It feels like, and the press releases for more build outs are continuing. So compact cables, connectivity, um, smarter connectivity solutions equals speed of deployment, and that is the name of the game, as referenced in the case study. Arguably more important than a cost savings is a reduction in the time it takes to deploy, and that is also a requirement, as many hyperscalers are choosing contracts based on who can deploy it fastest, and we'll continue to see more of that in the foreseeable future. And then there's new technology coming. It might be some of it's upon us, some of it will be over the next couple of years. Um, we, as an industry, have to continue to innovate and push the ball forward. Um, this is critical to meet the demands, because although this is a critical application, and data center interconnect is absolutely essential to the end applications. Um, if we can't solve a problem, then somebody else will. And I think a lot of eyes are on this industry. It's a great opportunity to grow, but one that we have to answer to the demands of the market today. So yeah, in summary, I think from a data centers interconnect standpoint, it is an often overlooked aspect of the network, but again, very critical. I've heard someone recently say, AI is a application. It's not a data center. And in order to enable that application and enable a data center, there's got to be transmission of data there, and that's coming from these metro and long haul networks, and it can't be done without them. And those closest to it recognize that, and we'll continue to see opportunities in this space going forward. So with that, that concludes my time here. We'll be happy to take a couple of questions,
Right.
Sean,
Yeah. All right. Well, I'm
to
gonna kind
wrap
of
it all up.
bounce back and forth a little bit between mine. Someone just said nice presentation, so I'll pass it on to you. Here's one, and I mean it's kind of a specific question. Maybe you can follow up with him. But what is the baseline cost per 100 mile on which the savings are subtracted, and the number of fibers involved in this cost? Maybe that's something you might have talked a little bit about in the case study, perhaps, or maybe this varies, as you said, case by case. Yeah, that's one question that
Yeah,
came.
the application there was a 432 fiber cable and an 864. It was a combination of those. So it was a little bit of a blend. Um, Again, it was really intended to be more of a general summary.
Yeah,
So we can cover that one separately, and happy to do something like
yeah,
that on a specific basis with more information on a specific case.
sure, sure. Yeah, I know everything. It would definitely vary. I mean, even before we got on to this call, I mentioned this 3 or 4 like smaller carriers that are doing DCI. But let me ask you. I mean, using existing pathways. I mean, certainly that would probably vary by customer. But again, one of the things that stuck out for me is the time savings. And you showed that picture of the choked open vault there with all the fibers coming out, and the water bottle. Talk a little bit about that a little bit more, and how that's helping. I mean, again, I'm assuming it varies by customer, because like a small fiber provider somewhere might not have as much fiber, but maybe like a larger carrier might. I don't know. I'm just curious about that. I assume this applies to everybody that's trying to deploy stuff. Yeah.
Yeah, I mean, I think we've seen a lot of, even before data center interconnect,
Right.
um, the microduct override capability over the last 5 years or so has been a game changer. I showed an example of the two 2-inch conduits with two 432 fiber cables in
Right.
there. Applications like that, where you've got an existing maybe 432 fiber cable, and in order to put that same size cable in, you'd need an additional pathway. Instead, you could do something like an 1814 microduct override and put some type of micro cable in there, even if it's 144 or 288 fibers. Um, Significant savings in time and financially there versus boring in a totally new pathway next to it. So micro
Right.
technology and microducts have really changed the game. And it was before DCI. I mean, that's been in the
Right.
last
Right.
5 or 10 years that that's become popular. But I think it's a great use case for this
Yeah.
space as speed is critical, fiber counts trending higher. Fiber
Mhm.
cables continue to get smaller, so you've got more options. Um, and are trending towards even higher densities on microducts and microcables.
Yeah, of course, many other things that for last mile networks and enterprises as well. Let me ask you a little bit about the hollow core fiber phenomenon, which I've been kind of bumping into for the past year. I mean, is AFL getting kind of actively involved in that? I mean, is supporting that? I mean, I know it seems to me still early days. I even know a small uh, startup company that actually is starting to work with folks like not AFL specifically, but just other
Yeah,
fiber, sort of manufacturers, and is getting some momentum. But I'm just wondering where's AFL stand with that? I mean, to me, it seems early days still, but just curious. Yeah,
it's early. We're certainly still in the research and development phase from our side, working with partners. There are certainly partners available out there that are non-traditional fiber manufacturers that are making that type of fiber and working with cabling manufacturers like ourselves to put that in cables. We're highly involved on the splicing aspect of it with our the Fujikura
uh,
element of AFL being an industry leader in splicing.
right,
So we have
right,
a splicer available today. It's more of a lab grade splicer than a field splicer today, but working towards getting that into a more compact space to splice it together. But it's definitely a specialty fiber. Fujikura has
yeah,
been splicing specialty fibers for a long time and
yeah.
has a lot of experience there and capabilities. Um, but there's certainly more work to be done from the hollow core front. But it's taken the industry by storm in some ways
Hmm.
over the last 12 plus months, and many of the big names that you would think of are deploying it now.
Yeah, yeah. No, we saw some announcements through a startup company and some other companies. And I guess like I mean, another question here was how do you splice hollow core fiber? But I'm sure again for Fujikawa being doing this kind of doing this for decades probably has a like you said has a early version of doing that, but I'm sure there's going to be different things that you'll discover over time. Yeah. Right.
Yeah, I mean, hollow core um, has been around for a long time. It's just
Yeah.
gotten to its commercialized stage. So
Right.
there's been a lot of runway from a handling and splicing standpoint on that. That's been over the last, honestly, probably 20 plus years, if you can believe it.
Yeah.
And it's
Yeah.
just kind of gotten to um,
The forefront.
gotten to the point where we can actually put it in the ground.
Right. Yeah. No, even some of the folks that I know. Let me talk a little bit about labor, and I mean, seems to me one of the great things about your product and some others that I know that some of your competitors is that it kind of enable there's like an ease of use here. It makes the installation process a little bit simpler. We talked about the pathways, but certainly, AFL has lots of different. You talked about like the multi element fibers before, and kind of adding more density and for pathways. But tell me a little bit about that. How it helps someone that, let's say, if I'm a smaller provider or a larger guy like a Lumen or whoever, deploying fiber for a data center. A customer, how does that help the labor force kind of get things done? Again, they're all trying to keep up with with AI and AI time, I
Yeah.
guess, if you will. Yeah.
Yeah, I think that's a great point, Sean, because we have these conversations pretty regularly where something might meet an industry standard, but would be um, would be a challenge to handle or deploy in the field. So, and not trying to limit innovation, but there are some limits where we
Yeah.
can have discussions with maybe an end user and say you might be going a little bit too fast on this, and there's an element
Pull it
where
back. Yeah.
in something that looks really good on paper might not actually work very well from a handling standpoint, because let's be honest, there are
Right.
a lot of contractors and installers out there that are on their first week on the job, and our applications
Yeah.
and field engineering team are working with those folks on a weekly basis. um, if our products aren't being installed correctly, it doesn't do anybody any good. So
Yeah.
I think that there is a tension to hold there of pushing innovation to a point where it's not field practical,
I
and
see. Yeah.
we've got to cover that balance. I think in some ways it's good we have direct relationships with these end users. AFL is very involved with the hyperscale market on the data center side as well. So having those
Right.
relationships helps, where we say, this might look good, but here are our concerns on how this is going to be deployed.
Yeah. Yeah. And you don't want to be, getting customers upset that things aren't being delivered on time and because of some mistake, kind of rein it
Yeah.
back in. Um, in terms of, I mean, AFL, of course, has the backing of Frederick Howard, and you, of course, serve the largest providers all over the world. But I mean, I'm also seeing kind of a tendency for smaller markets building out data centers. I mean, I'm just curious to see, just in general, what AFL is seeing in terms of demand. I mean, of course, we got the tier one NFL markets, but like I said, I've been having conversations with smaller service providers that are now getting into the
Yeah.
not as data center providers, but providing fiber and wavelength services to like some of these other places, that because there's only so many places you can put a data center, and it seems like
A,
they're expanding out. Yeah,
a lot of them are chasing rural spaces, which are
yeah,
spaces where traditional service providers have not been. So there's been a big opportunity for the smaller providers as well. And these hyperscalers do not discriminate on that, and they will find where they can get what they need.
mm,
And when it comes to data center interconnect, we've seen a lot of smaller players get involved in this too, and have, I think, to their value, whether it's a lease network or however it's worked out, have the financial backing of the larger player to get them involved. So I think it's good for everybody.
yeah,
But there is certainly some rural parts of the country that these data centers are going to. So um, yeah, it's been everybody across the board, from the biggest names you can think of
yeah,
to some
yeah.
smaller mom and pop shops.
Right. And another trend you mentioned, and it's something again that I'm following pretty closely, the 400 to 800G. I mean, we see it on the wavelength services side, of course. You're also going to have folks that are going to say, "Well, I don't want wavelengths. I want dark fiber going into my data center." I mean,
Yeah.
what's? I mean, I assume AFL is probably seeing all the above. And you guys are like kind of in the middle of all that, providing the infrastructure that you provide. I don't know if you had any thoughts about that, or just in
Yeah,
general.
I mean, we are involved to the degree that our customers are talking about it. Um, we're primarily a passive optical infrastructure provider, so we're not as
Right.
directly
Right.
engaged with on the active side. I mentioned it in the presentation, as I think it's a benefit to
Yeah.
um, the data center interconnect. Is I mean, the theoretical bandwidth of these optical fibers is crazy, and so as we
Mm,
continue to innovate on the blinky light side, as some of our sales team likes to say, that interstate pathway of an optical fiber is going to be valuable for a long time. There's some limitations, and we've
yeah.
got to work through that.
Right.
But we're hearing a lot about 800 gig within the building. Some of that more kind of going outside of the
Yeah.
building, but it's great. It's great to see innovation there, and it challenges us to be better on our side too.
Yeah, no, gives you more opportunities to compete, and certainly, we could have a whole other discussion about wavelength services and other things and the way people want to manage stuff. Let me get back to at the end of the end of the presentation, you talked about multi-core fiber. Just just give us a little bit of an update of where AFL is with that. Having the Fujikawa relationship and having those guys be your parent. I mean, certainly they can
Yeah.
help drive a lot of that innovation through AFL as well. But just curious to see what you see, how that market evolving. Seems to me some still sort of early, but yeah.
Yeah, it's still early, but it's been going on for a while. I mentioned
Yeah,
there we were
yeah,
doing a field trial for that 5+ years ago. So it
right.
has been ongoing. The demand hasn't really taken off. It's a little bit of a catch-22 of or chicken and the egg of hasn't really been a commitment on the demand side for it to push it from research to field deployment. Um, we're working on it. Fujikura is working on it. I think we could see some commercialization of that product by the end, probably the back end of the decade is the time frame that
Okay,
I would estimate now.
right.
Um, but it is if there was an immediate demand for it, honestly similar to what we saw with Holocore. It went
Mhm.
from research project to hey, we're going to do this, and then some others followed, and it's kind of pushed the industry to make it ready. We haven't
Yeah.
quite seen that on multi-core because its value is not the cost benefit. It's not quite there yet. I think from an end user standpoint.
I guess more to come as we go. And the other exciting thing that I'm kind of seeing is just kind of an observation is sometimes we're seeing data centers go in and then, people using the fiber for other things. Certain service providers like Astound Broadband has an agreement with AWS and they're using part of the fiber. They're backhauling to go into other things like to deliver fiber to the home in rural markets. So it's kind of an exciting
Yeah,
time. I think that's and a lot of opportunity for AFL to play too, because I mean, you guys are like again the blocking and tackling in the middle of all that. Great. Well, I guess once we're kind of getting to the end here, I figure maybe if I could just have you close out with just some closing thoughts, and we can bring this in for a landing. But I think you had some really great insights today, and like I said, this gives me some other things for me to ask when I'm out talking to my fiber provider friends about
yeah.
DCI. So thank you for that. Yeah. If we could just wrap up with some final thoughts from you, Carson, I'd really appreciate it. Yeah.
Sure. Happy to take any additional questions. I know we got some other ones in the chat which we can cover too, but if anyone wants to reach out to me directly, is
Yeah.
my email address there and the AFL website. We appreciate the time here from Lightwave and appreciate getting
Yeah.
to cover a very uh, a topic we talk about a lot internally, and one for good reason, because the amount of fiber scaling on these metro and long haul networks is really pushing the global industry to make more fiber and
Yeah.
other connectivity components for it too. So we're excited. I've mentioned the stat earlier about these AI data centers basically being small cities when it comes to fiber to the home. We
Right.
could have never
Right.
dreamed what kind of bandwidth they would require and what's next after that. We don't know. And I know the market's taken a little bit of a hit this week from AI jitters. I talked to one large hyperscaler last week when some of the quarterly reports had come out and said, "Is any of this concerning you guys?" Basically,
Mm.
and they said, "No, we're going to continue to build." Um, so I
Wow.
think that's been a lot of the mentality of the major players is again the fear to miss out is bigger than the concerns about the debt that's being piled up on this, and we're starting to see um, some ROI on this, but it'll be fascinating to watch, and we'll
Yeah.
continue to be a part of it. And as mentioned previously too, I think we've got to continue to innovate. We can't sit still and think that this is good enough because
Right.
we've got to provide solutions to this market that will continue to grow over the next years and decades potentially.
Yeah, for sure. Even as well as just AI for consumers, but even in the enterprise, all the news we're seeing about that, how enterprises want to evolve and take advantage of new cloud services, that's going to require a lot more data centers, which more business for AFL and other connectivity providers like yourselves to kind of to get in and get into the mix and make things happen. So I think that's what people should realize, is that there's a lot of components to these networks. But again, thank you, Carson, for your great presentation. As we list here, feel free to reach out to Carson if you like. If you have other questions, I always hope that there's always ongoing dialogue after a webinar, but you can feel free to reach out to him and through the presentation here. But I just wanted to thank everybody for joining us today. Thanks AFL for sponsoring another great webinar. And I hope to see folks more. I think this is an exciting topic, and I think we're going to be talking about more things this year on DCI as well as into next year. But again, thanks for your time, Carson, and thanks to AFL for sponsoring. And I hope everybody has a great day. Thank you very much.
Sure.